logarithmic functions. Now, a logarithm is just the inverse of an exponential function. We know an exponential function is in the form y is equal to a to the power x. So a can be any base raised to the power x. That's exponential. So this same exponential function, I can convert it to a logarithm. How? I'll just say log. This is the base. So it will also become the base of the logarithm. This answer will be here. And then the power becomes the answer. So say log of y in base a is equal to x. If you want to convert back, just get the base to the power x is equal to y. So you go like that. That's basically a base. I mean a logarithm. When you have got a logarithm, let me say an exponential function. Let's say y is equal to 2 to the power x. This one as a logarithm is going to be log in base 2 of y is equal to x. When you have got y being equal to 10 to the power x, as a logarithm, you just say log of y is equal to x. So a logarithm in base 10, you don't show the base. And then if you have got an exponential function of Euler's number e, let's say you have got e to the power x, this is about 2.7, it is a very special number, then you are going to have log in base e of y is equal to x. And log in base e is a special log which we call a natural log. So this will just be natural log of y is equal to x. Basically, this is it. Okay. Now, what are some of the special properties that we get to deal with when you're talking about logarithms? First property is a property of addition. When you are adding logs of the same base, so log of a plus log of b, simply multiply the a and b. This is going to be log of ab. When you are subtracting logarithms of the same base, let's say, so if I say natural log of a minus natural log of b, these are logarithms of the same base that are all in base e. So this is going to be written as natural log of a over b. You simply divide. Okay. When you have got a log which is having a power, this power can come in front, so that is going to be b log of a, like that. And then another property, when you have got an exponential function that is raised to a log, the base of the exponential function is the same as the base of the log. This it will just give you b, it will just give you this value here, as long as the base of the exponential and the base of the log are the same. That is what we are going to have. So from this property, now using these same properties which are here, we are able to work out different logarithms. Just maybe something I need to mention is that when you have got a log you want to change to another base, let's say log in base 2 of 4, I can convert this base, this logarithm, to base 4 or to any other base that I want. And how do I do that? I'll just say log, I'll take to the base I want. Let me say I want to go to base 4, put 4 here. And then I'll copy this for the same way it is. And then also divide. Remember I'm changing to base 4, so again write a 4 here. But what was the base? This 2 now comes here. So basically I've converted from base 2 to base 4. But I can simplify this. This is going to be log. This is a special property when you have got log of 4 in base 4. These are some special properties. I'm going to mention them. And then divided by, this is going to be log in base 4. 2 we know we can also write it as 4 to the power 1 over 2. So this 1 over 2 I can also bring it in front. As we saw, the power of a logarithm can come in front. Now this log can cancel with this log. Or what I'll just say is that log of 4 in base 4 is a 1. Log of 4 in base 4 is 1. So this is going to be 1 divided by 1 over 2. the answer is going to be a 2. So basically that is the evaluation of these logs. You can convert from any base just like that. Let's say we have got a logarithm in base, okay, let's say we've been asked to evaluate 3 raised to the power log in base 9 of 2. How can we evaluate this logarithm? First thing first, we need to make sure that this base and this base are the same. And how do you do that? We know that 3 is the same as 9 to the power 1 over 2, right? From our exponential function. And this is raised to the power log 9, 2. And this we can also write as 9. We know from our exponential functions we can remove the bracket. So this is going to be 1 over 2 log in base 9 of 2. Now we know that when a number is in front, we can take it as a power of this number which is here. So this is going to be 9 log in base 9, 2 to the power 1 over 2. When we reach this point, we can see we have got 9 here, we have got a 9 here, meaning that the answer will just be the same 2 to the power 1 over 2, which we can also write as the square root of 2. So that is going to be the answer for this logarithm. Are we good?
Yeah, we're good.
Okay. Now, some special properties that I just mentioned. We know that when you have got, let's say, any number raised to the power 0, the answer is 1. This is from an exponential. So if I express this as a log, this is going to be log of base 2. So instead of me writing 2 here, because we know that it is basically any number, let me put x. Okay, so I'm going to say log the base is x. Log of anything of 1 where there is a 1 here, the answer will always be a 0. We have converted this exponential to a logarithm. As long as you can see a 1 here, we don't care the base, it will always give you 0. That is a property. And then when you have got, let's say, x raised to the power 1, we know that the answer will always be x. So writing this as a logarithm, this is going to be log, the base is x of what? X is going to be equal to 1. You know that when you convert back, this will be x to the power 1 is equal to x. So as long as these two are the same, the answer will always be 1. So these are just simple properties that we are able to follow like that. Now let's see how we are going to be able to apply these logarithms in solving equations and simultaneous equations. Let's say we've been given that x multiplied by y is equal to 64, and we've also been told that log in base x of y plus log in base y of x is equal to 5 over 2. So the question is solve for x and y. What are we able to do for this case? So I'm going to start with the logarithm. Make sure that I express it in the same base. How are we able to do that? So let me express in base x. So this is the log in base x of y plus. So we have got log in base y of x. I want to convert it to base x. So this is going to be log. Now the base becomes x. Remember there is x here. Keep it the same way it is. And then divided by log. Remember we are going to base x, put x here, but this is a y, so this is the one which comes here, and that is going to be equal to 5 over 2. We know that log in base x of x is a 1, so this is going to be log in base x of y plus 1 divided by log in base x of 1 is equal to 5 over 2. So at this point I'll say let anything that you want, let b be equal to log in base x of y. Okay, so at every point where I'm seeing log in base x of y, I'm going to put b. So this is going to be b plus 1 over b is equal to 5 over 2. I can multiply everything by b. This is going to be b squared. Actually, let me not multiply just by b, but let me multiply by 2b, because I can see b and 2 in the denominator. So b multiplied by 2b, that is going to be 2b squared, and then plus 1 over b multiplied by 2b, that is going to be 2. That will be equal to 5 over 2 multiplied by 2b, that is going to be 5b. Take them to the same side. 2b squared minus 5b plus 2 is equal to 0. The product is 4, the sum is negative 5. What are the factors? What are the factors? No one can get me. Richard, what will be the factors here? Caristo. Hmm? Oh, we are lost.
I think -4 and 1.
So 2b squared minus 4b minus b plus 2, negative 4 and negative 1, and that will be equal to 0. So this is going to be 2b, b minus 2, we'll remove a negative 1 here, b minus 2, that will be equal to 0, giving us 2b minus 1, b minus 2 being equal to 0. So we are going to find that b is going to be equal to 1 over 2, or b is going to be equal to 2. I'll remove this. I'll also remove this. Now I'll go back and say, remember our interest is not in b, okay? But we know that log in base x of y is equal to b. That's the one of our interest. So I'm going to say log in base x of y is equal to 1 over 2, or log in base x of y is equal to 2. Now express this as exponential function. So this is x to the power 1 over 2 is equal to y, or x to the power 2 is equal to y. Now we already have another equation here. Make x have the formula, or even y, x is going to be 64 over y. So this is going to be x to the power. Okay, let me substitute where there is x. Now for that case, let me make y substitute the formula to be much easier. So y is equal to 64 over x. So this is going to be x to the power 1 over 2 is equal to, where there is y, we are going to put 64 over x, or x squared is equal to, where there is y, still put 64 over x. Cross multiply. X to the power 1 multiplied by x, same basis multiplying, just add the power. So 1 plus x, that will be x to the power 3 over 2. That is going to be equal to 64, or x squared times x, that will be x cubed. That will be equal to 64. When solving exponential functions, it's very easy. So just multiply by the reciprocal of the power 2 over 3, also here by 2 over 3. So x is going to be, what this means is you can write this as this root of 64. What is down will be the nth root. So this is the third root or cube root. And then what is on top will be the power. Or x here multiplied by 1 over 3, even this side by 1 over 3. So this will just be cube root of 64. Meaning that x is equal to the cube root of 64. What number can we multiply 3 times to get 64? Is that a 4? And then 4 squared, that is 16, or x is equal to the cube root of 64, that is just a 4. Now that we have found x, we can go on and also find y. And how do you find y? Just go in the equation. So when x is equal to 16, y is going to be 64 over 16, and y is going to be equal to 4. When x is equal to 16, y is going to be 64. Oh, I've actually substituted different things here. Okay, y is going to be 64 over no, it's okay, and y is going to give us How many times will 16 go into 64? Or maybe it's my punching which is wrong. How many times is 16 going to 64? That's the one giving us 4, right? I've both gotten 16, so one I'm supposed to get a 4 instead of 16 for both sides. So for this one I'm getting a 4, and y is going to be 64 over 4. Y is going to be now 16. So we have found the values of x and y. Are we good?
Yes.
Okay, let's consider another one. Let's say we've been given to solve the first one. We want, without using a calculator, evaluate log in base 0.5 of 16. How can we evaluate this one? Remember, the aim will be to use the rules. So this is going to be log base 0.5. I can also write that as 1 over 2 of 16. So my aim is to write more 16 as in base 1 over 2. Now that might be a bit of hard. So what I'll do is I'm going to convert this to another base which I might work with better. Sorry for this. So now the question is, what base is that which I'm able to work with better? I can convert to base 4. Okay, I'm able to do that. Or even 16 itself, 16 I can write as 2 to the power something. Like there are a million of ways to do something. So this is log of 4 in base 1 over 2. 16 is the same as 2 to the power what? To the power 4, like this, okay? Like that. Now, remember the base here is 1 over 2. I want also this one to have 1 over 2. So the question is how? We know the rules. So if I make this to be 1 over 2, meaning that this 2 which has gone down, the power will become negative 4. So that is the trick here. And this will be log in base 1 over 2, and that is going to be 1 over 2 the power negative 4. Okay, like that. And when you have got this, we can bring the 4 in front. That will be negative 4 log base 1 over 2 of 1 over 2. And this will just be negative 4. So that is how one way that we are able to get this. Another way is we can convert to another base. Let's say we convert to base 4 or base 2. So this is going to be log in base 2 of 16 divided by log in base 2. What was the base now comes here, 1 over 2. And this is going to give us log in base 2. 16 is 2 to the power 4 divided by log in base 2. 1 over 2, we know that that's the same as 2 to the power negative 1. We know that. We can bring the 4 in front and then log in base 2 of 2. Can bring the negative 1 in front and then log in base 2 of 2. So these two cancel. The answer is still negative 4. So that is another way that we are able to use. Whatsoever that is good for you, go for it. Okay, we can also work out another one. Without using a calculator, evaluate log in base 10 of 0.001. So basically just make sure that the bases are the same. So this is going to be log in base 10. Now 0.001, of course it has got infinite number of zeros this side which we're able not to see. So my aim is to write this as 10 with something, alright, with a power. And how do I write that? I'll move the decimal 1, 2, 3. I'll move it for the fourth time so that the point goes beyond this 0. So that is going to be 10. I moved it 1, 2, 3, 4 times, isn't it? 1, 2, 3, 4 times. That is 10 to the power negative 4. Okay, I think that is it. Then the negative 4 can come in front, and that is going to be negative 4 log in base 10 of 10, and we can tell what the answer is. Do you have any question? By the way, for this one, even if I've written the negative 4, that will not even be the answer. There is a misjudgment here. Let me do this again. We have got 0.001, and this written in exponential form, we are going to have 1 goes once, twice, and then for the third time. So if it reaches here, the answer is going to be 1. So if we forgot how we write numbers in exponential form, that is going to be 1. You always multiply by 10 now to the power negative 3. So if I move it again, that would have been 10 multiplied by 10 to the power negative 3. I meant to the power negative 4. So that is the tricky part when you're converting. So this is 10 to the power negative 3, because this is just 1 times 10 to the power negative 3, not going again to give us a 10. Otherwise, that is going to be 10 multiplied by 10 to the power negative 4, which is still 10 to the power negative 3. So the answer here is a negative 3. Are we good with that? Are we good?
Yeah.
Okay, let's consider another one. We want to solve natural log of 1 over x plus natural log of 2x raised to the power 3 is equal to natural log of 8. The question might be, how do we get to solve this one? To solve it, we are going to take everything to the same side. We're going to have natural log of 1 over x plus natural log of 2x to the power 3 minus natural log of 8 is equal to 0. We know that logs, subtracting and adding, we know the rules which apply. So this is going to be natural log of the 1 over x, because it's adding with this one, so meaning that they are going to multiply. Okay, multiply by 2 x to the power 3, but because this one is subtracting, so we're going to divide, and that is going to be equal to 0. We know that the base of a natural log, this is actually the same as log in base e, natural log. So we'll say e, that is the base raised to the power 0, and that is going to be equal to, these two can cancel with 8, that is going to be x, or actually also the 1x here can cancel with 1x here, so we're going to have x squared over 4. Any number raised to the power 0, the answer is 1, so this is going to be 1 is equal to x squared over 4. Crossing and multiplying x squared is going to be equal to 4. Okay, and this will give us x being equal to positive or negative 2. Now when you have got a logarithm, take note of this. Let's say we have got log of negative 2 is equal to x. Let's try to write this in exponential form. So the base here is 10, so meaning that 10 to the power x is equal to negative 2. There is no power such that when you raise 10 to, it will give you a negative 2. In other words, this value which is here for a logarithm can't be negative, so that's why you only pick the positive part. Therefore x is going to be just positive 2. Can't pick the negative part. Okay, we can consider another one. Let's say we want to solve log in base 16 of x plus log in base 16 of 10x plus 3 is equal to 1 over 2. How do you get to go about it? So this one is direct because the bases are the same and it is adding. So simply multiply these terms, x multiplied by 10x plus 3, and that is going to be 1 over 2. Now express it in exponential form, so 16 to the power 1 over 2, and that is going to be equal to x times 10x, that will be 10x squared plus 3x. 16 to the power 1 over 2 is the square root of 16, and that is going to be 4. That is going to be equal to 10x squared plus 3x. Take them to the same side. 10x squared plus 3x minus 4 is equal to 0. The product is 40. The sum, the product is negative 40. The sum is 3. What two numbers do we think can do that work for us? Such that when we multiply, we get negative 40. When we add, we get a 3. Any two numbers? If we consider 8 and 5, 8 and 5, so this is going to be 10x squared. The 8 should be positive, 5 should be negative, and then 4 go to 0. So this is going to be 2x open brackets. What is going to remain? 5x plus 4, and then we'll remove a negative 1, 5x plus 4, that will be equal to 0, and this is going to give us 2x minus 1, 5x plus 4 equal to 0, meaning that x is going to be 1 over 2, or x is going to be equal to negative 4 over 5. So these are the values of x. Are we good with this?
Good.
Okay, thank you. Let's look at another one. Let's say we've been told to solve x to the power log in base x of x is equal to x to the power 3 divided by 100. How do we get to solve it? Now, when you look at the base, the bases are the same here. The power is a log, meaning that the answer is just x. So x to the power log of x in base x is simply x, and that is going to be equal to x to the power 3 over 100. So here I can multiply both sides by 1 over x, such that this x will cancel with this x will cancel with 1x, so we're going to have 1 is equal to x squared over 100, and that will give us x squared being equal to 100, and x is going to be positive or negative 10. So that is going to be it. But remember, basically we want to avoid the negative number, so therefore x will be just positive 10. As simple and as direct as that. Okay, the next one. Question is asking us to find the integer values of the product yz. So it's saying find yz. Given that y is equal to log in base a of x to the power 3, and then z is equal to log in base x of a. We want to find the product. Now the question is, how do you get the product? So we'll get this yz, y multiplied by z. This is going to be log in base a of x to the power 3 multiplied by log in base x of a. I don't think we know of any rules which are going to help us to get to wherever we want to go. But remember the question, find the integer value. I mentioned that already, meaning that the answer is supposed to be an integer. Okay, so from the properties of logarithms which we know, I can bring this 3 in front, isn't it? Now before then we can see that these are of different bases. Let me convert the other one to the same base. So this will be yz is equal to log in base a of x to the power 3 multiplied by log in base a of a divided, I'm taking to base a. Okay, just change the base and then maintain this term divided by log. We are going to base a and then put x here like that. So this will be yz is equal to, I'll bring the 3 in front, and that will be log in base a of x multiplied by log of in base a of a is 1 divided by log in base a of x. So this term will basically cancel with this term, meaning that the integer value for yz is 3. Are we good with that? Are we okay?
So what's the final answer?
Final answer is 3. Okay, let's consider the last question. Log in base 2 of x plus 4 log in base x.
Stop.
Pardon? There is something? Okay. Just I want to solve this equation. Log in base 2 of x plus 4 log in base x of 2 is equal to 5. How do you get to go about it? You need to make sure that we convert it to the same base. Let me convert from base 2 to base x. So this is going to be log. We are going to x of x divided by log of x, and then we put a 2 here. And then that plus 4 log in base x of 2, that is going to be equal to 5. We know log of x in base x is a 1 divided by log base x of 2 plus 4 log in base x of 2, that is going to be equal to 5. So at this point I'll just let any number, let's say p, be equal to log in base x of 2. So meaning this is going to be 1 over p plus 4p, that will be equal to 5. To remove the fraction, multiply everything by p, to be 1 plus 4p squared is equal to 5p. Take to the same side, 4p squared minus 5p plus 1 is equal to 0. The product is 4, the sum is negative 5, so the factors should be negative 4p and negative p plus 1, that would be equal to 0. So give us 4p, p minus 1, then negative 1, p minus 1 is equal to 0. So giving us 4p minus 1, p minus 1 being equal to 0. From there we'll see that when we solve for p is going to be equal to 1 over 4, or p is going to be equal to positive 1. Now remember our aim was not to find p but x. We'll say but log in base x of 2 is equal to p. So meaning that log in base x of 2 is equal to 1 over 4, or log in base x of 2 is equal to 1. So if I express this as an exponential function, this is going to be x to the power 1 over 4 is equal to 2, or x to the power 1 is equal to 2. To solve this first one, I'll multiply here by 4, also here by 4, meaning that x is going to be equal to 16, or x is equal to 2. So these will be the values of x for this one.